Okay, so now let's take a look at these examples. It says that the population of Sundarnagar is, well, it's supposed to be the name of some place in India. The population of Sundarnagar was basically 235,471 in the year 1991. In the year 2001, it was found to be increased by 72,958. What was the population of the city in 2001? So basically, so essentially we have the population in 1991, which is essentially this number, and then in 2001 the same number was increased by essentially 72,958. And now we want to know essentially the population of the city in 2001, which is simple. Well, and essentially what's important here is the word, essentially the keyword here is increased by this number, right? So when you increase a number by another number, then of course you will essentially use addition, and this here is why. So now suppose that you have a number 2 and you want to increase essentially 2 by, for example, by the amount 5, for example, right? So which means that essentially if you think of this as suppose that this is a 1 on a number line, and then 2, and then 3, 4, 5, 6, 7, and 8, right? So you have essentially the number, you have the number 2 over here, and if you want to increase it essentially by 5, you will have essentially, this is 1 unit increase, this is another unit increase, another unit, another unit, and another unit. So that's essentially 1, 2, 3, 4, and 5 steps, right? So so essentially that means that you start at 2 and then you increase it by 5, which means that essentially you're adding 5 to your number basically. So then to calculate this, to essentially to increase 2 by 5, you would write 2 plus 5 is equal to 7. So your number 2 has been increased to 7, right? By essentially by the amount 5 basically. So 2 has been increased to 7, or essentially you could say that you have increased 2 essentially by 5, right? And what this and essentially what this also means is that essentially when you increase a number by any amount, essentially to calculate the result, you always of course have to do addition. Essentially it's exactly the same situation as if you had, for example, 2 pebbles, and now you increase your number of pebbles essentially by another 3 pebbles, for example, right? So then in order to know essentially now the total number of pebbles that you have, you essentially put all of them together and you count 1, 2, 3, 4, and 5. So this is the same thing as essentially 2 plus 3, which is equal to 5, right? So that's basically that. Now essentially over here in 1991 our population was 235,471 people and that was in 1991. And then basically in 2001 it was increased by 72,958. So plus a 72,958 basically. So if I do this calculation, I'll have 8 plus 1 is equal to 9, 12, we carry over 1, that's a 14, carry over 1, that's an 8, that's a 10 carry over 1, and that's a 3. So that means that essentially by the year 2001 the population was essentially 308,429 people basically, which is essentially the amount over here. Now that essentially sometimes when you're adding your numbers, so essentially for example when you add your numbers, you can add them this way and you can just simply take care of the problem. Of course there is no problem with that. But then sometimes, for example, you have let me see, it was 235,471. It was 235,471. And suppose that you want to add to this number, for example, I don't know, what was that? A 72,958. 72,958 basically, right? So you can do essentially long addition, but essentially if your numbers are in such a way that essentially you would be benefited from essentially ripping your number apart, you can do that as well, meaning that essentially 235,471 is actually nothing but, so essentially you have the ones place value, the 10, the 100, the 1,000, the 10,000, and the 100,000. So this 2 over here is in the 100,000 place value, which means that that's the same thing as 2 times 100,000, right? And then basically this 3 is in the 10,000 place value, which means that essentially that's the same thing as 3 times 10,000. And then this 5 is in the 1,000 place value, so that's 5 times basically 1,000. This 4 is in the hundreds place value, so that's 4 times basically 100, right? This 7 is in the tens place value, that's 7 times a 10 basically. And this 1 is in the ones place value, so that's 1 times 1 basically, right? And then if you do this these different parts, if you calculate them, that's a 200,000, that's a 30,000, that's a 5,000, that's a 400, and that's a 70, and that's a 1 basically. So this essentially this number essentially you can write it this way as well. And sometimes, and then essentially the other number, for example 72,958, 72,958, you can write it as essentially 70,000 plus a 2,000 plus a 900, for example, plus a 50 plus an 8 basically, right? And then sometimes it's going to be helpful, meaning that then essentially then if you were to essentially add essentially these two numbers together, you can essentially take a look at these parts and see that, for example, a 70,000 and a 200,000, for example, they will go together very easily. Or a 70,000, a 30,000, that's 100,000. So I can just simply essentially add these two parts together and write it as for example as 100,000. And then, for example, these two parts, for example, I can add together 5,000 plus 2,000 would be essentially 7,000. If 400 and 900 would be a 1,300, I can add them together. I'm just giving you essentially ideas and example. Otherwise, I wouldn't really do this. I mean, sometimes it's beneficial, of course. A 7050 is, for example, is 120. A 1 and an 8 is essentially a 9, and then we have essentially this part over here as well, which is essentially 100,000, 200,000, and then somehow essentially put all of these together in order to get to essentially to your number basically. Okay, so that's basically that. Now the next question that we have here is, in one state the number of bicycles sold in the year 2003 was 743,000. In the year 2003-2004, the number of bicycles sold was 800,100. In which year were more bicycles sold and how many? So essentially in the year essentially 2002, 2003, the number of bicycles sold was 743,000 bicycles were sold, right? In 2003-2004, the number of bicycles sold was 800,100. Now, now the question is, in which year was the number of bicycles essentially was the number of bicycles sold higher, and how many basically? So what you can do is that essentially you want to essentially compare these two numbers, right? You want to know essentially of course, in order to compare the numbers, you just simply have to compare, right? And to compare the numbers, I write essentially 800,100 and 743,000, and then you see that both the numbers have essentially 6 digits. So then I will take a look at the largest digits in the two numbers. Here I have an 8, here I have a 7, which means that I have essentially 8 groups of 100,000s in this number. I have 7 groups of 100,000s in this number, which means that the value of this digit is 800,000, the value of this digit is only 700,000. So of course this number is greater, right? But then by how much, right? The question asks essentially the question also asks basically in which year basically were more bicycles sold and how many more. So in order to know essentially how many more, you need to essentially check how much this number is larger than the other number, right? Which is easy to calculate. You need to just find the difference between the two numbers, right? So I will write over here, and we can also practice our subtraction as well as a little bit. So we have essentially 800,100, and then basically we have 800,100, and we have 743,000, and you want to subtract, and of course when you subtract, as you can see, I'm subtracting the smaller number from the larger number, and there is a reason for this. Essentially, of course, you might when you subtract the smaller number from the larger number, you're just simply calculating how many bicycles more were sold in the second year, right? And meaning that you're just simply calculating the difference between the two numbers. But then if you essentially subtract the larger number from the smaller number, then you will come up essentially with a negative number in some context that has essentially its own applications, but essentially not here. Here we just want to find the difference basically, right? So now 0, essentially 0 minus 0 is equal to 0, right? Or essentially, if I add a 0 to this 0, I'm going to get a 0, right? Again, 0 minus 0 is equal to 0. Or if I add this 0 to this 0, I will get this 0. Now, 1 minus 0 is equal to 1. Meaning that, essentially, if I add this 1 to this 0, I will get this 1. Or you could simply ask, essentially, what number do I have to add to 0 to get a 1? And that number is 1. Now, here, essentially, we want to take away, essentially, 3 from a 0, which is not possible. So, and so in such cases, essentially, in such cases, in multiplication, you have to essentially borrow something from the other place values so that you can essentially complete the operation, basically. And the way that you do that is that you see over here, essentially I have, essentially this is the 1, 10, and 100, and this is the thousands place value. So this is essentially the thousands place value. This over here is the 10,000s place value. And this over here is the 100,000s place value, right? Now, I have 0 groups of thousands, basically. I have 0 groups of 10,000s, and I have essentially 8 groups of 100,000s in this number, right? And of course, there is nothing here, so I have to have something here so that I can take away 3 of them. So, and as you can see, I cannot borrow from the 10,000s place value because there is nothing there. There is just a 0, right? So then what I'm going to do is that I'm going to say that, of course, I'll have to borrow from here, basically. And so I have essentially 8 groups of 100,000s, basically, over here. Over here, I have 8 groups of 100,000s. Now, from these 8 groups, I will keep essentially 7 of them, and I will break one of them up. So now I have this one group over here, this group of essentially 100,000, and I want to essentially to break it up. Now, if I break this up, I will get essentially how many groups of 10,000 will I get? So I will get essentially 10 groups of essentially 10,000, right? 10 times 10,000 is essentially 100,000. So then I will put this 10 groups of 10,000, essentially for these groups, I will put a 10 over here, which means that now essentially I have 7 groups of 100,000s and 10 groups of 10,000s, right? But still my problem is not solved because essentially still I need to essentially bring something over here. And now, but now essentially I can borrow this from the 10,000s place value. So these 10 groups of 10,000, I will keep one. I will essentially keep 9 of them. I will keep 9 of them, and one of them I will break up, right? I will break up one of them. So essentially now over here I have one group of essentially 10,000 over here, and I can do whatever I want to do with this. So, but then essentially one group of 10,000 is essentially 10 groups of 1,000, right? 10 times 1,000 is a 10,000. So, and this is essentially the thousands place value. So I put a 10 over here, which means that I have now essentially 10 groups of thousands over here, and now basically in total, basically now what happened here is that I have now, instead of essentially 0 groups and 0 groups and 8 groups, I have now 7, 9, and 10, meaning 7 groups of 100,000, 9 groups of 10,000, and 10 groups of 1,000 basically. And now we can essentially do our operation. Okay. Now, in case this confused you, I'm going to, once we go through this operation, I will explain this one more time so that you can understand it better than so that you can actually use it. So now 10 minus 3 is equal to 7, or essentially 7 plus 3 is equal to 10, and 9 minus 4 is equal to 5, or 5 plus 4 is equal to 9, and a 7 minus 7 is equal to 0. So the number is supposed to be 57,100, right? And let me check the answer over here to make sure that I didn't make any mistakes. So we had 800,100 minus 743,000, and that's 5,700. Now, as you can see, the answer is correct, but going through this operation this time, every time, essentially, of course, you need to understand these place values, and sometimes when you want to borrow something from other place values, you actually need to go through this exact process. Sometimes things get a little bit complicated, so you need to break things down as I did here. But otherwise, it's a lot of work if you want to do this every time. So a simpler way to do this is that I had essentially my numbers were 800, 100, and 7, 4, 3, 0, 0, 0, and then do the essentially subtraction. Now what you learn in school is essentially the simpler version that I'm explaining right now. So usually essentially teachers teach the students to say essentially to go like this: 0 minus 0 is equal to 0, right? 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 0 minus 3 is not possible, so now you have to borrow. So of course, whenever you want to borrow, you have to borrow from the next place value, which is not possible. So you go to the next place value over here, and then you just simply borrow 1 from the 8. So that means essentially you have 8. You have essentially 8 minus 1 is equal to 7. So you cross this and you write a 7 over here. But then when essentially now you have essentially one group over here that you want to bring it over here, right? You have to bring it to the next place value. But then that 1, when it comes to the next place value, they tell you to write it as a 10. Okay? They tell you to write it as a 10. And usually students essentially do this just essentially by memorizing that essentially when the 1 is transferred to the next place value, it's just simply written as 10 basically. They don't really know essentially why, but they do that. And of course it works, of course, because it's not wrong, but they don't know what they're doing. And then basically again we have to give something to the next place value. So I cross this, I borrow a 1 from this 10, so this 10 becomes a 9. And then essentially the 1, I have to, essentially the one group that I borrowed from here, I will have to bring it essentially to this place value. And then when that 1 essentially comes over there, it becomes a 10. So I write a 10 over here, a 9, and a 7. So it's exactly what I wrote over here. But here, of course, I did this based on the essentially based on the values of the different place values and based on my own reasoning. But essentially students usually do this. Now what I mean by this is that when I mean, once you have understood, essentially, once you can reason your way through essentially all of these different kinds of calculations, when you can use your reasoning there, then you can essentially easily use these techniques without any problem, because essentially all of these techniques do work. But then the reasoning behind that also has to be in your mind, because sometimes you actually need to use it. Okay, so then you can go 10 minus 3 is equal to 7, 9 minus 4 is equal to 5, and 7 minus 7 is equal to 0, and you get essentially the exact same thing, 57,100, 57,100. So that's essentially your subtraction, basically. Okay, now now the question is and how many more is 57,100, which we also calculated over here. So that's basically that. So this was example number 1 and 2. In the next video we will talk about example number 3. Thank you. Okay, so hello, welcome back. Now in this video we'll talk about example number 3, which is essentially the town newspaper is published excuse me. The town newspaper is published every day. So one copy has basically 12 pages, and every day 11,980 copies are printed every day. How many total pages are printed every day? Okay, now this kind of question, of course, it's not very confusing, but it's not very straightforward, meaning that, of course, I can say that essentially one copy has 12 pages, and so essentially then since essentially 11,980 copies are printed every day, so I have this many copies in a day, and so essentially one copy would have essentially 12 pages, so many copies would have essentially this number times this number pages, meaning 11,980 times 12 pages, basically. So then essentially the total number of pages would be 12 times essentially 11,980 pages, basically, but then every day, so you have to specify that as well. Okay, so now if you can essentially read the question, and if you can understand it, and if you can essentially solve the problem this way, this solution is more than enough, and I suppose the book has essentially solved the problem in the exact same way. Let's see what they've done. They said that each copy has 12 pages, and it's 11,980 copies will have 12 times so many pages. So what would this number be? More than 100,000 or less? And so they have essentially done an estimation, which is not important right now, but they have essentially solved the problem this way. Right? Now sometimes essentially the problem confuses you, and you cannot basically so essentially you cannot find the solution this way properly. So there is another way to essentially to solve such problems, using essentially the proportions that we used before. Okay, and what that is that basically we know that essentially one copy has 12 pages. So then that means that I can say essentially one copy. So I can essentially write this as, for example, 12 pages per copy, for example. Or the same thing, I can write it also as essentially, for example, one copy, for example, per 12 pages. I can write it in any way that I want, really. This is essentially 12 pages per copy, which means that for every 12 pages, I will have one copy. This is essentially one copy per 12 pages, which means that essentially for every copy, I have 12 pages, both of which essentially mean the same thing, basically, right? Now, every day, so many copies are printed. So essentially, we have essentially 11,980 copies per day, basically, per day. Or I could say that essentially in one day, I have essentially 11,980 copies. I can write it this way as well, right? Both mean the same thing. Now what we want to know is that the total pages that are printed every day. Total pages that are printed every day. So here essentially I'm looking for the total number of pages every day, right? So how do I solve this problem? So you have to, again, essentially you have to play with your proportions. You can play with your proportions, and that gives you the solution very easily. Meaning that essentially you will start with the information that has been given to you in the problem. For example, in the problem, it's been given to you that essentially every copy essentially contains 12 pages. So I can write essentially 12 pages per essentially one copy, right? And you have to also keep in mind what you're actually looking for. You're looking for total number of pages every day, meaning the day has to be there, and then the number of pages also has to be there. And so over here, essentially, as you can see, the page is there, right? The day is not there, so I'm going to have to essentially to bring in the day somehow, and then the copy is there, which is something that I don't need. So I need to essentially I need to somehow get rid of the copy, and then keep the page and somehow bring in the day as well. So that's essentially how you solve this kind of problem. And you can, of course, you can keep multiplying it essentially in a string, meaning that, for example, I have essentially written this piece of information over here. If I say that basically, if I say that essentially you have essentially 11,000. Let's write this as, let me show you something over here. Now you see that essentially in the second piece of information is either this variation or this variation, right? Now if I write it this way, meaning one day, meaning essentially one day per essentially 11,980, for example, copies, right? Then basically and remember that I wanted to get rid of the copy, basically, because the copy is something that I do not need essentially in my final answer. So now the day, essentially I have brought in the day, right? The page is there, but then the copy essentially is there, and there is no way for me to get rid of it, right? Whereas if I had written basically the same piece of information that we had over here, if I had written it the other way around, meaning that if I had essentially used this first variation over here, then what I would have would be essentially 11,980 copies per 1 day, right? Now you can see that essentially you have this unit copy over here and copy in the numerator and the denominator. You can cancel them out. And so now what remains is that 12 times this number, and then you have the page and you have the day, right? So then you would write this as 12 times basically 11,980 pages per day basically. And that's exactly what we were looking for. In the first, essentially in the first solution, we had the exact same thing, 12 times 11,980 pages per day. And that's essentially how you can essentially solve these types of problems where you have something depends on something else, and then again that thing depends on something else, and then again that thing depends on something else, and so on and so forth. So that's essentially how you solve your problem. Okay, now once you get essentially your problem, now this type of question, when you ask this type of question about basically the number of pages of a certain newspaper in a whole town, usually you don't care about each and every one of those pages, meaning that you don't want to know the number essentially down to the last page basically. You want to know essentially an estimate. You want to estimate, and based on that estimate, then you will have some sort of idea basically how many people live in that city and that sort of thing, right? So now instead of essentially actually doing this calculation, what I'm going to do is that I'm going to estimate. I'm going to say that essentially this number over here, 11,980, it's very close to a 10,000, right? Very close to a 10,000. And the number 12 is, well, of course, very close to a 10. And, well, 10 times the 10,000 is essentially 100,000. But this is essentially, this number still doesn't answer my question. And I think I forgot to actually ask the question. The question that I wanted to ask was that essentially now this number, is it going to be above 100,000 or essentially below 100,000? And the estimate that I got is exactly 100,000, right? So now in order to answer this question, I take a look at my numbers, and I can see that essentially now in my estimation, instead of 12 times essentially this number, I wrote this as a 10 times the 10,000 basically, right? Now I have essentially the 12, I have rounded it down to get a 10 so that the calculation becomes easier. And this number is almost at 12,000, right? Very close to a 12,000. And I have rounded that down to a 10,000. So of course, meaning that essentially I have rounded down everything in order to get to this calculation, which means that, and this estimated calculation gave me essentially 100,000, which means that if I do the actual calculation, it's definitely going to give me some number well above essentially 100,000. And you can see that they have done the operation over here, and the answer is 143,760. Okay, so which means that essentially in this town, basically every day, 143,760 pages are printed, or essentially you could also read that as 1,43,760 in the Indian system of numeration, basically. Okay, so the next question, so we have essentially the number of sheets of paper available for making notebooks is 75,000. So that means essentially we have 75,000 sheets of paper available, right? Each sheet makes 8 pages of a notebook. So that means essentially one sheet per 8 pages of a notebook. And each notebook contains 200 pages. So one notebook per 200 pages. How many notebooks can be made from the paper available, right? So this is again one of those questions that something depends on another thing depends, and that thing depends on yet another thing, and so on, and so it might be a little bit confusing. So if I have essentially 75,000 sheets, and if one sheet essentially makes 8 pages of a notebook, then 75,000 sheets are going to make essentially 75 times 8 essentially pages of a notebook. So this is the number of pages of a notebook, right? And so that means that essentially now we have so many pages available. Now we want to know essentially how many notebooks we can make. So then essentially if one notebook contains 200 pages, then that means that essentially for one notebook you need 200, for 2 notebooks 400, for 3 notebooks 600, and so on and so forth. So then if I divide this whole number of pages that I have by essentially by the number of pages of a notebook, by the number of pages required essentially for one notebook, this gives me essentially the number of basically the number of notebooks that I can make, right? And if you do this calculation, you can see that this is essentially 75,000 times an 8, which is a 600,000, and then 600,000 when you divide it essentially by 200, that gives you 3,000, which seems to be essentially the answer that they've gotten over here, right? Although the first time that I tried to essentially to solve the problem, I actually got confused in the solution, basically. So this is not the way that I would actually solve the problem. I would still follow my own order of essentially putting things together in form of essentially proportions, cancel things out to get essentially the answer. But still, we can take a look at the solution over here first. It says each sheet essentially makes 8 pages. Here we said basically each sheet makes 8 pages of a notebook. Hence 75,000 sheets make essentially 8 times 75,000 sheets. That's essentially what we did in the first stage, basically. Thus 600,000 pages are available for making notebooks. That's exactly what I happen to do. Now 200 pages make one notebook, hence 600,000 pages make essentially 600,000 divided by 200 notebooks. And then when you divide essentially 600,000 by 200, you would get essentially 3,000, the number of notebooks that you can make, right? So this is one way that you can solve this problem. Another way is essentially to make this a little bit simpler, meaning that you have essentially 75,000 sheets over here. You have essentially the number of available sheets is essentially 75,000 sheets of paper. Now if each sheet makes essentially 8 pages of a notebook, so one sheet 8 pages. So if I multiply that by essentially and I remember that I want to get rid of sheet over here, because what I want to end up with is essentially only essentially the number of notebooks. So because I want to get rid of essentially the sheet over here, and of course this sheet is essentially just a number that I'm multiplying essentially by these numbers. So you can think of this as essentially as 75,000 sheets essentially per one, right? Meaning that this sheet is actually in the numerator. Whatever essentially in calculation, A times B plus C over D, for example, times, for example, this, times, for example, E over F, times, for example, G, for example. Suppose that you have this calculation, and these are, well, some numbers basically. You see over here, when you have essentially a fraction, for example, C over D, this fraction has a numerator and a denominator. Again, this fraction has a numerator, it has a denominator. But then these numbers that you write over here like A, like for example, like a 1, like a 2, like a 3, like a 4. But then these fractions would be like, for example, 4/5, right? So these are essentially whole numbers. These are essentially fractions, right? Or essentially you can think of them as division essentially. So in the case of a fraction, you have your numerator, and also you have essentially your your denominator. In the case of a whole number like this, the number itself becomes a numerator, because essentially the number 3, you can write it as essentially 3 ones, essentially 3, and with the denominator 1, meaning when you divide essentially any number by a 1, the value of the number, of course, is not going to change. So in the case of essentially this number, or this number, these numbers are essentially the numerator itself, and then the denominator is a 1, so we don't write them, right? So then basically over here, I want to get rid of this unit of sheet over here, right? And it's in the numerator. So now I need to essentially write this thing. I need to write this thing over here. So each sheet makes essentially 8 pages. So that means essentially one sheet per basically 8 pages, right? So then naturally, because of the fact that I want to get rid of the sheet over here, I have to write this sheet in the denominator, so that this sheet is in the denominator and this sheet is in the numerator, so that they will cancel. You can cancel them out basically. So then I will write the sheet over here, one sheet per essentially 8 pages, or essentially 8 pages per one sheet basically, right? So still I need to add a couple of things to this, so that because still the notebook hasn't appeared here yet, right? Now each notebook contains 200 pages. Now again, I want to get rid of this. Now I have already gotten rid of the sheet over here because they will cancel out, but still I want to get rid of the page. So I will multiply this basically by essentially 200 pages, and the 200 pages I write them I write it in the denominator, so that it basically cancels out with the page over here in the numerator. And then 200 pages would mean essentially one notebook, right? So this way essentially you don't have to do essentially first a multiplication and then a division. Everything essentially simply comes together. So now sheet and sheet you can cancel out, page and page you can cancel out, and you have to be very careful with this, so as not to forget anything. You have a 75,000 here, you have an 8 over here, you have a 200 over here, and you have a notebook over here. And well, then essentially multiplying by a 1 or essentially dividing by 1 is not a problem, because whenever you multiply something by 1, the value doesn't change. Whenever you divide by 1, the value, so you can just simply ignore them, right? So this would be the same thing as essentially 75,000. This would be the same thing as essentially 75,000 times basically an 8 divided by 200, and then the unit essentially becomes notebooks, right? And then you can do the same calculation, meaning that first you will multiply essentially 75,000 times an 8, which is essentially what we had essentially over here. You can do this part first, and then that calculation becomes essentially 600,000, and then basically you can do this part of the calculation, which is essentially the 600,000 divided by 200, which gives you 3,000. So that's essentially 3,000 notebooks. Okay, so that's essentially how you can solve these types of problems in two different ways, whichever one you basically you prefer. In the next video, we will talk about, we will work a little bit on exercise 1.2, and thank you. Okay, so hello and welcome back. Now in this video, we will talk about the concept of proportions. And essentially I'm doing this video on proportions because of the fact that it's something very important. You're going to, I mean, we are going to need to use it almost everywhere, in essentially in all of our exercises and everywhere. And well, the concept has not been introduced yet in this textbook. There is a chapter on proportions somewhere in class 6 basically, and we are going to study proportions in detail over there. But for now, well, of course, since we have to use it, I will introduce it. I will essentially point out to a couple of its properties, and then later on we will essentially do it in more detail basically. Okay, so basically what is a proportion, or essentially what is the concept of a proportion? So let's say that essentially that you read a book, essentially not the, let's say that, for example, a number of pages of a book. For example, you read 5 pages of a book in, for example, in 15 minutes. So if you read 5 pages of a book in 15 minutes, right? Now, if I keep up the same speed, meaning that if I don't change the speed, for example, sometimes sometimes you might read essentially faster, sometimes you might read slower, but if you just simply not do that, meaning that if you keep your speed absolutely constant, if you keep up the same speed, then essentially I can say that since you read essentially 5 pages in 15 minutes, then for example twice the number of pages, meaning 2 times 5 pages, you would read in twice the amount of time, meaning essentially in 2 times 15 minutes, right? Or essentially 3 times the number of pages, 3 times 5 pages, you would read in 3 times basically the amount of time, 3 times 15 minutes, and so on and so forth. And of course you can keep going with this, meaning that you can then say that, for example, 4 times the number of pages, you will finish in 4 times the amount of time. 5 times 5 times, 6 times 6 times, and so on and so forth, right? So then based on this, I can say that essentially you read essentially 5 pages in basically in 15 minutes. Or essentially you read, for example, 2 times 5, which is 10 pages, in basically 2 times 15, which is equal to 30 minutes. Or basically you read 3 times 5, which is 15 pages, in essentially 3 times 15, which is equal to 45 minutes, and so on and so forth. And of course you can just simply keep going with this, right? And because of the fact that basically that these essentially all of these proportions are based on the original piece of information that we had over here, we could essentially say that essentially all of these proportions are essentially equal, because of the fact that essentially 5 pages in 15 minutes is exactly the same thing as, for example, 10 pages in 30 minutes is exactly the same thing as 15 pages in 45 minutes, and so on and so forth. So instead of essentially separating these with commas, I can just simply say that these are simply equal, right? They just simply refer to the exact same thing, right? And then just for a second, if I just simply forget about the page and minutes in the numerator and the denominator, I can then simply write 5 over 15 is the same thing as basically 10 over 30 is the same thing as 15 over 45, and so on and so forth, right? And here you can see that basically 5 times 2 is equal to 10, and 15 times 2 is the same thing as 30. So times 2 and times 2. Or basically over here, you can see that basically 5 times 3 is equal to 15, and 15 times 3 is equal to 45. And so by the same logic, then I could say that basically, for example, 5 times 4 is equal to 20, and 15 times 4 is equal to 60. So this would be basically 5 times of 4 is equal to 20, and 15 times of 4 is equal to 60. Which means that essentially then you would read basically, for example, 20 pages in 60 minutes. And you can just keep going with that, right? So then, essentially you can see that you can multiply both the numerator and the denominator of the fraction by the same number to come up with another fraction which is equal to the original fraction, right? And well, because of the fact that essentially multiplication and division are inverse processes, meaning that they are related together, instead of multiplying you can divide, right? Because you see over here, we say that, for example, 20 divided by 60 is the same thing as, for example, 5 divided by 15. Now, if over here, if I take a 20 and multiply it by, if I take the 20 and now instead of multiplying, divide by 4. If I just simply divide by 4, then if I will get a 5, and if I take a 60 and divide by 4, I will get a 15. Again over here, if I take the 15, for example, divide by 3, I'll get a 5. 45 divide by 3, I'll get a 15, right? And so essentially, which means that essentially when you have essentially any sort of fraction, you can multiply essentially both the numerator and the denominator by the same number to get essentially a fraction which is equal, which would be equal to the original fraction. Or essentially you can go the other way around. You can start with the original fraction and divide both numerator and denominator by the same number, and then you will get essentially a fraction whose value is exactly the same as the original fraction, basically. Right? Now, one more thing that we have essentially in these fractions is that essentially if you take two fractions, for example these two fractions over here, you can always cross multiply with these fractions. And what do I mean by cross multiply? So you can take essentially your fraction over here, and well, cross multiply means, well, cross multiply, meaning essentially cross the numbers like this, and then you have the equal sign over here. So then if I want to cross multiply, I will say essentially 20 times this 15 is equal to, and the equal sign comes from here, and now we have the essentially, now we need to multiply essentially the other two numbers which would be essentially 60 times of 5, right? Now you know that essentially 20 times of 15 is the same thing as 2 times 20 times 15 is the same thing as 2 times 10 times of 15, and you know that 2 times of 15 is equal to 30 times of 10, which is equal to 300, right? So this side is essentially 300. And one thing that I would absolutely recommend to you, if you're new with mathematics, or essentially if you haven't done mathematics in a long time, chances are that you have already forgotten all of the mathematics that you knew before. So calculation is going to be not easy for you. And if you're new to mathematics, again, calculation is not going to be very easy for you. So in the beginning, you start essentially doing your all of the calculation that we have essentially in all of these courses. Do your calculation manually. Don't use essentially calculators, things like that. Do your calculation manually, and then once you're and of course it's going to take a little bit of time, for example a year, 2 years, if you're then essentially if you do mathematics for a couple of years, then after a couple of years you will start feeling comfortable with calculation, with manual calculation, and then you can essentially switch over to essentially to calculators if you like to. And chances are you don't really, I mean, once you get good enough at calculation, you will really not want to switch over to calculators, essentially because, well, numbers are essentially, once you work with them for a couple of years, they become essentially something like your friends, and then you will enjoy spending time with them. Okay? And moreover, essentially as a result of this process of going through your calculations manually, other very valuable things will start happening in your mind, which is going to be very valuable in your mathematics. Okay? So you can just, I mean, you can just follow what I said over here, but then you have to be patient enough to do your calculations manually by hand for a couple of years, and then you will see essentially what happens. And a 60 times 5 is the same thing as a 6 times a 10 times a 5. A 6 times a 5 is a 30 times a 10 is a 300. So you see that essentially a 300 is equal to 300, which means that essentially you take this number over here and multiply it by this number, right, which is 20 times 15, is exactly equal to essentially to, again, you take this number and multiply it by this number, 60 times 5, which is equal to 300. This relationship is always going to exist essentially among all of these four numbers, basically. And the reason I'm mentioning this is that essentially sometimes you have, for example, a number like for it, some calculation. For example, you're trying to solve an equation or something like that, and so essentially you have something like for example 2/3 is equal to, for example, 9 over x, and you want to calculate the value of x, right? So then you can essentially cross multiply. You can say essentially 2 times x is the same thing as 3 times 9, right? And this is basically your x. So then basically you would write essentially 2 times x is the same thing as 27, and then you can essentially use the way that we use to solve equations. Essentially you take essentially this number over here, which is alone on one side of the equation, which is 27, and then divide it by one of these numbers, either 2 or x. Basically I'm going to divide by 2, and that's going to be equal to the value of x, which is essentially x. So essentially then you can say that x is equal to 27 by 2, which is something like, for example, 13.5 or something like that. And of course this is supposed to be equal to 13.5, but because of the fact that we haven't still talked about decimal numbers, we will talk about that in the next video, and you will understand what is exactly the meaning of 13.5 or essentially any decimal number like that. Okay, so that's basically all that you need to know for now about proportions. And in the next video we will talk about decimal numbers. I'll see you in the next video, and thank you. Okay, so hello, welcome back. Now in this video we will talk about essentially about decimal numbers, and you also need to be aware of the fact that essentially there is something that we call decimal numbers, and there is also something called that we call the decimal number. This is decimal numbers, let's say decimal number system, and these two things are completely different things, meaning that essentially decimal numbers are essentially one type of number essentially in the decimal number system. In the decimal number system essentially you can have, well, different types of numbers, meaning that you can have, for example, integers, real numbers, imaginary numbers, fractions, essentially whole numbers, natural numbers, all of those things. Basically these are the different categories of numbers that essentially can occur in the decimal number system. Okay, and basically the decimal number system is essentially nothing but is essentially a number system, right? A number system is essentially well, it's just simply a system of numbers. Basically what that means is that, for example, when you write, for example, 123, or essentially a 5, or essentially a 658, or a, for example, 574, for example, now based on what do you know that, for example, you have to put the 3 first as the first digit, for example, in the number. Then essentially based on what do you know that you need to put essentially the 2 next to 3, basically. And then based on what do you know that you have to put the 1 essentially over here, right? So based on what do you know essentially all of these things? You know essentially all of these things based on the fact that, for example, we have talked about the decimal number system in this course, in the previous course, and so then we talked about essentially all of these place values, and we said that, for example, this is the ones place value, this is the tens place value, this is the hundreds place value, and for example the ones place value, that means essentially For example, a 3 in the 1's place value, that means 3 groups of 1. The 2 essentially in the 10's place value, that means 2 groups of 10 basically, which means a 20. A 1 in the 100's place value, that means 1 group of 100, which means essentially 100, right? And we saw essentially all of those pebbles and bars and essentially all of those boxes and everything that we used, and we said that the value of this is 1, so that appears here in the 1's place value. The value of this is essentially 10 of these ones, that appears in the 10's place value. That's 100, that appears over here. And essentially all of these rules and regulations, when you put them together, that becomes essentially a system that using which essentially you can make numbers, right? And then well, essentially this system has been called essentially the decimal number system because of the fact that basically that in this system, because of the fact that this is a base 10 number system. A base 10 number system meaning that you have essentially all of these digits 0, 1, 2, 3 all the way up to 9. Essentially you have 10 digits over here. You have 10 digits over here. And so essentially if you have a 10 digit number, you can fill this place value with any of these 10 digits. You can fill this place value with any of these digits, and so on and so forth. So because of the fact that it's a base 10 number system, meaning essentially you have 10 of these digits over here, using which you can essentially fill any of these place values, the number has been called a decimal number system. Otherwise, we have also the octal number system, in which we have essentially instead of 10 digits, we have essentially 8 digits. We have the binary number system, in which essentially we have only 2 digits for every place value. We have the hexadecimal number system, in which we have essentially 16 digits, meaning each of the place values can be filled with any one of the 16 basically digits basically. Okay. So this is a number system, which means that essentially this is a whole complete system based on which you can actually make numbers. Okay. And so essentially any number that we write in mathematics, or any number that is used among humans, is in the decimal number system. For example, a 1, a 2, a 3, a 4, for example, a 123, a 526, and so on and so forth. These are all numbers that have been created in the decimal number system. Okay. Now, in the decimal number system, you can create essentially different types of numbers. For example, you can create essentially natural numbers. You can create natural numbers. You can create basically, I don't know, whole numbers. You can create, for example, I don't know, fractions, for example. You can create, for example, real numbers. You can create, for example, imaginary numbers. You can create essentially complex numbers. You can create complex numbers, and so on and so forth, right? Now, these are different types of numbers. We will get familiar with each and every one of them as we go through the different chapters. But one of the different types of numbers that you can create essentially in this system is essentially the real number. Now, the real number in a specific context, you can also call it essentially the decimal number. You can call it the decimal number. And essentially a decimal number, essentially the difference between essentially a decimal number and a non-decimal number is that the decimal number has the decimal point and essentially the decimal digits to the right of the decimal point. Meaning that, for example, decimal number looks like 1234.56, right? Now this over here, this is essentially a decimal number. And you have essentially this part over here, which is essentially called the whole part. Meaning that essentially the number 1234 all the way up to here is actually a whole number. Meaning the whole numbers essentially in mathematics would be 1, 2, 3, 4, 5, 6, all the way up to infinity, including 0. Essentially all of these are basically whole numbers. So this part over here is called the whole part. And then we have this part over here, which is called the decimal part. This part over here is called the decimal part. And this point that we use over here, which essentially separates the decimal part from the whole part, this is called the decimal point. Right? This is called essentially the decimal point. So that's essentially a decimal number. Essentially in contrast to the decimal number, you have all the other numbers which are not decimal numbers. For example, 123. This is not the decimal number. This is a whole number. And this is not a decimal number because there is no decimal point, there is no decimal part. Essentially none of those things exist in the number essentially. So this number is not a decimal number, and this number is a decimal number because, well, you have a decimal part and you have the decimal point. Right? Now, you are familiar with the structure of the decimal number system. We have already talked about that before. So, for example, when you say a 100, 1, 2, 3, 4, for example, 1234, we saw that essentially this is the ones place value. This over here is the tens place value. This over here is the hundreds place value. This over here is the thousands place value, and so on and so forth. And you can just keep going in this number. You can just keep going towards the left, write more digits over here. You'll get 10,000 place value, 100,000, a million, 10 million, 100 million, so on and so forth, right? And you already essentially know what it means to say essentially the ones place value, the tens place value. So when we say essentially, when you put a 4 in the ones place value, that means essentially you have 4 of those pebbles, four of those loose pebbles, and each of them has a value of 1. So 4 ones essentially would be a 4. When you put essentially 10 of these pebbles together, you get a rod like this. So that's essentially 10 of these pebbles, the value of which essentially becomes a 10. And then basically when you put the 3 in the tens place value, that means essentially you have 3 of these rods over here whose value essentially becomes a 30. 3 times 10 is equal to 30. Now if you put essentially 10 of these rods together, you will have essentially something like this, some box like this. That's essentially 10 of these tens, which is essentially 100. And so when you put a 2 essentially over here, that means essentially 2 of these boxes of 100, whose value essentially together becomes a 200, for example. And then again, when you put essentially 10 of these boxes together, that becomes 10 times 100, which is 1,000. So that's essentially a 1 over here. That means essentially one of those bigger 1,000 boxes, basically. So that's the meaning of these place values in a number that doesn't have the the decimal point and the decimal part basically. Now if I put a decimal point over here, and then if I put a 5 for example and a 6 over here, right, then this place, so then now my number is a decimal number, and so then essentially this is called the 1/10th place value, and this place value is called essentially the 100th place value. Okay, now you see essentially in this number, when I start from the decimal point and move towards the left, every time essentially I move to the next place value, I have to essentially take the previous place value, multiply it by 10 to get the value of this place value over here. So 1 times a 10 is a 10. 10 times a 10 is 100. 100 times a 10 is 1000. So as we move essentially towards the left, essentially each place value is multiplied by a factor of 10, and so essentially we are constantly increasing essentially the value of these place values as we move towards the left, right? And then basically, and then if you come over here at the place value, at the decimal point, and if you move towards the right, you see over here essentially when I move towards the left, I'm multiplying by a factor of 10. But then as I move towards the right, I am actually dividing by a factor of 10. Meaning essentially the place value over here is the 1's place value. Now 1 divided by 10 is 1/10. Again, 1/10 divided by 10 is a 100th. Again, 100th divided by 10 would be a 1000th. The next one essentially would appear here. Again, the 1000th divided by 10 would be a 1/10,000th, which would be a digit over here, and so on and so forth, right? So to the right of the decimal point, as you move towards the right, you will be dividing by 10, meaning that the value of the place values essentially keep getting smaller and smaller, because a 100th is smaller than a 1/10. Then a 1000th would be smaller than 100. Then a 1/10,000th would be smaller than a 1000, and so on and so forth. But then to the left of the place value, as we move towards the left, basically these place values are multiplied by a factor of 10, which means that when you move to the next place value, the value of the place values are essentially increasing and increasing and increasing basically, right? So now we already know essentially the meaning of these place values. For example, the 1's place value would be essentially one of these pebbles, or essentially one of these cubes, right? And then 10 of these cubes you put together, you get a bar like this, and then 10 of these bars you put together, you get a box like this, and so on and so forth, right? But what is the value of the 1/10th? What is essentially the meaning of the 1/10th place value in terms of essentially these cubes and boxes? Suppose that essentially I have this cube over here, and something I make it a little bit larger so that we can work with it, and I will divide this cube into 10 equal parts. So that's essentially 1, 2, 3, 4, and 5, and then all divided by 2, that would be essentially 10 equal parts. So remember that the value of this box is just a 1, meaning that it's the exact same box that I have over here. I have just simply enlarged it, and then I have divided the same thing into 10 equal parts basically, right? Now if I take basically essentially the one of these equal parts, the value of this one, the value of this part over here would be essentially 1/10, because essentially it is one of 10 equal, basically 10 equal parts. It's one of 10 equal parts basically. So the value of this part over here would be 1/10, right? So then when we say, for example, a 0.56, that's essentially a 5 in the 1/10 place value, right? Which is essentially, so this would be essentially a 5/10, right? Which is essentially 5 times 1/10, which would be essentially one of these 1/10, excuse me, which would be 5 of these. So if I take essentially, if I take all the 5 over here and shade them, this whole part over here would be 5/10. Okay, this whole part is, if this is 1, if the whole thing is 1, then these 5 parts over here together would be 5/10, because it's 5 out of 10 equal parts basically, right? Now, what is the meaning of this digit over here, which is this 6 in the 100th place value? The meaning of this digit is again very simple. So first of all, this is essentially a 600th, meaning a 6 out of 100 equal parts. And the 600th is essentially nothing but 6 times 100th. Because essentially you are in the 100th place value and you have essentially a 6 over here, so 6 times 100th would be a 600th. Now, how do you understand 600th essentially in terms of essentially these box models? So if I go over here, the same box, and if I, now this is essentially a box whose value is just 1, and I have essentially divided this box into essentially 10 equal parts. So that's 1, 2, 3, 4, 5, and another 5, so that would be a 10 basically. So again, what I will do is that I say that this is 1, 2, 3, 4, and 5, and then divide the whole thing by 2, and then suppose that essentially now this part is now divided into 10 equal parts. And I will do the same thing over here, the same thing over here, and so on and so forth for all the parts. So then this is 10 equal parts, 10, 20, 30, 40, 50, 60, 70, 80, 80, 90, and 100. So that means that essentially now this whole box has been divided into 100 equal parts. Right? Now if I pick basically this one box over here, the value of this small box would be essentially a 100th, meaning essentially 1 out of 100 equal parts. And so then basically a 600th would be a 6 out of 100 equal parts, which would be essentially 2, 4, and 6 over here. So the value of this part would be then 600, meaning 6 of those 100 equal parts. So that's the meaning of a decimal number. And of course, you know that essentially a decimal number has, well, everything to do with fractions basically. Meaning that, and of course you know that fractions have essentially everything to do with division, right? So essentially when you take, for example, when you divide essentially when you write 2 divided by 3, it's going to be something like, I think 67%, if I'm not mistaken. 2 divided by 30. That's 67%, or 0.67 essentially. This thing over here, essentially 2 divided by 3, you can essentially write it as 2 divided by 3 as well. Or you could write it as 2 divided by 3, or 2/3. So this thing over here is called a fraction. And of course, you know that these are essentially simple division, essentially, right? So 2/3, when you give it to your calculator, of course you can do long division as well, and then you will get the exact same thing. Sometime when we find the right time, I will do essentially a long division with this type of numbers, in the case of which you will get essentially this type of result, like 0 point something. We will do that later on. But essentially when you do this division, you will get essentially 0.666 and so on and so forth, and then of course the calculator now has rounded the number, so the last digit, essentially the calculator has made it a 7. Otherwise it's just 0.666 all the way up to infinity. So then this is the same thing as 0.66. For example, you could just keep, you could I mean, if you want to write 0.666 and so on and so forth, you would just simply write it as 0.6 and put a bar over here, which means that this 6 essentially keeps repeating, right? So this is essentially a decimal number. And of course you can imagine that 0.6 or 0.6 essentially is a number which is smaller than 1. If I write essentially a 0.5, this is essentially the same thing as a half. This is essentially half of 1. 0.6 is a little bit larger than 0.5, right? But it's still smaller than 1, because essentially in your number, in the ones place value you have a 0, and in the 1/10 place value essentially you have a 6, which means that it's essentially 6/10 basically. And so essentially when you have essentially a fraction like this, you can write it essentially as a decimal number as well, which we will discuss essentially later on when we make this a little bit more advanced. Then we will talk essentially all about these fractions and decimal numbers and all of those things. And if you have essentially, for example, some fraction like 3/2, then you would write it as as essentially a 1.5, right? So you see that essentially in this fraction you have essentially 3 in the numerator, 2 in the denominator, and you see that the numerator is larger than the denominator, right? So the number essentially turns out to be essentially larger than a 1. So you have a 1 over here, you have a 0.5 over here. So essentially the number is a half larger than 1 basically. But then when you divide a smaller number by a larger number, you will get essentially a number which is essentially less than 1, which means that then you will get some number like 0.6, 0.3, 0.7, something like that basically. Hopefully this video was, you have understood the meaning of this, of these decimal numbers, which is important because then later on we will have to essentially use these decimal numbers in the 4 basic operations, because they will have to use them in addition, in subtraction, in division, and in multiplication. And when you go through, for example, long multiplication or long division, or essentially when you go through basically long addition and subtraction, that sort of thing, then of course you need to understand essentially the meaning and the value of these digits that come over here after the decimal point. so that you can do the different operations. Otherwise you will end up memorizing all of these things, which would not essentially be helpful in the courses that we are doing here. You need to understand. So that was all about decimal numbers, and in the next video we will talk about exercise 1.2. Thank you. Okay, so now let's talk about exercise 1.2, which is essentially we have 12 exercises here, and so the first one is basically a book exhibition. A book exhibition was held for 4 days in a school. The total number of tickets sold at the counter on the first, second, third, and final day was respectively 1,094, 1,812, 2,050, and 2,751. Find the total number of tickets sold on all the 4 days. So then essentially on the first day you have essentially so many tickets, on the second day so many tickets, and so on and so forth for all the 4 days. So the total number of tickets would be essentially all of these numbers essentially added together, which is something simple, and I will basically put all of these solutions for these exercises as well as a part of this course. Somewhere you can essentially, I will let you know essentially somewhere in the course, I will somehow let you know where to essentially download essentially all of these files, so that you can essentially open them, the book itself, and then also the solutions, everything I will put somewhere, attach it to one video, and then you can download it from that video. So then essentially all of these numbers you will essentially add together. Of course this is not the right way to write it. To write down essentially this addition, you would have to write it like this. Essentially all of these numbers that we have, you have to write them. Basically you have 1,094, so essentially all of these 4 numbers you would write essentially 1,094 plus 1,812 plus 2,050 plus 2,751, and then you would write the sum over here. That's one way to write it. Another way, you can essentially write 1,094 and 1,812 and 2,050 and then 2,751, and then add essentially all of these together, and then you would write the sum over here. So that's essentially different ways to write it. And of course you know addition, and you can do the addition yourself and then check your work with the calculator. So this is something simple. And then Shekhar is a famous cricket player. He has so far scored 6,980 runs in the test matches. He wishes to complete 10,000 runs. How many more runs does he need? So he has already made essentially so many runs, but he wants to make it to 10,000. So how many runs are missing? Now, in order to essentially, now let me quickly show you a model that you can essentially use for subtraction. So he has essentially 6,980 runs already made. So then basically we have over here So he has already made so many runs, and then he wants to make it to 10,000 runs. So how many more runs essentially does he need? So the model that you can use here is that essentially this is, let's say that this amount or this quantity is a 10,000, which is essentially the runs that he wants to make it to, basically. And he has already made basically this many runs, which is 6,980. And he has to make another, essentially this part as well. This part, let's call it X, for example. He essentially needs to make so many more runs to make it to a 10,000. So when you have this kind of situation, this is essentially the situation of a subtraction. And then in a subtraction, essentially you will essentially subtract. You will write down the whole number of runs that you want to make it to, meaning essentially a 10,000. This is the whole number of runs. And then the number of runs that he has already made, you will subtract from that, which is 6,980. And then whatever you get over here is actually essentially the number of X, basically. And then the number of runs that he has to make more of, so that he makes essentially a total number of it, essentially 10,000, right? Now this subtraction might be, you might find it useful. Let's go through this. So we have essentially a 10,000, and then essentially I want to subtract from that 6,980, right? I want to subtract. So now basically what I need to do is that from this 0 I want to subtract the 0, right? So 0 minus 0 is equal to 0, right? Here I have no problems. But then from this 0, meaning essentially 0 groups of 10, basically I want to subtract 8 groups of 10, which is of course not possible, because you need to have at least 8 groups of 10 from which you could essentially subtract 8 groups of 10, right? But there is 0 groups of 10 over here. So I have to essentially borrow from essentially either this digit or this place value. From any of these place value I have to borrow something, so that I have at least 8 groups of 10, so that I can subtract these 8 groups of 10 from essentially from those 8 groups of 10, basically, right? So you see that essentially over here I have again 0 groups of 10. From here, essentially over here again I have 0 groups of, so I cannot borrow anything here. The only place I can borrow is essentially from this place value, which is essentially the 10,000 place value, right? So I have one group of 10,000s, right? So I borrow essentially, so this is essentially nothing but this one over here represents essentially one group of 10,000, right? So if I borrow from this, and so the only thing that I can do is that I can essentially break this up, right? So I will break this up, and I have basically for one group of 10,000 I will have basically 10 groups of 1,000, because essentially you know that 10 times 1,000 is essentially a 10,000, right? So I will break up this group of 10,000, and I will get essentially 10 groups of 1,000, right? So then the groups of 1,000 essentially would be, essentially the thousands place value would be, this is 1, 10, 100, and 1,000. So now I will break this up, and I have 10 groups of thousands, basically, right? but still I need to keep bringing these groups over to the right so that eventually I have some groups over here so that I can do the subtraction. Then I will again, basically I will again have to essentially break these 10 groups of 1000. So I will break it up into essentially so 10 groups of 1000 I already have over here. So I will break it into essentially one group of 1000 plus 9 groups of 1000. So that's 1 times 1000 plus 9 times 1000, right? So one group of 1000 plus 9 groups of 1000, that would be essentially 10 groups of 1000, right? So again, I will break this up and make it one group plus a 9 group. The 9 group I will keep it here, and the one group of 1000, which is right over here, I will have to bring it to the hundreds place value, right? So one groups of 1000 is essentially simply 1000, which is essentially how many groups of 100? That's essentially 10 groups of 100. Right? So 10 groups of 100, I put them over here. So now I have 10 groups of 100 plus 9 groups of 1000. The 10 groups of 100 is 1000 plus a 9000. That's essentially a 10,000, which I originally borrowed from here. Right? So then again, basically I have 10 groups of basically hundreds over here, and again I have to break it up so that I can borrow from this and bring a couple of those groups essentially over here to the tens place value, right? So the 10 groups of 100, so I have 10 groups of 100, and I will break it up as essentially one group of 100 plus essentially another 9 groups of 100. So that's essentially 1 plus 9 is equal to 10 groups of 100. And then I will keep the 9 over here, so I break this up, keep the 9 groups over here, the 1 groups of 100 remains over here. Now I need to again break this up so that essentially I can somehow bring it to the tens place value. So 1 groups of 100 is essentially 100, which is nothing but essentially 10 groups of 10, right? So the 10 groups of 10, or essentially the 1 group of 100, which was from here. So then the 10 groups of 10, I bring them over here. Now I have essentially a 10 groups of 10, 9 groups of 100, and 9 groups of 1000. And if you essentially add them together, I mean, if you've done everything right, you should actually come up with the same 10,000 that you started with, because in this number the only digit that I had was essentially this one over here, which is essentially just a 10,000 basically. Okay? So I have 10 groups of 10, and I have 9 groups of 100, 9 groups of basically 100, and I have 9 groups of 1000. So this is the same thing as 10 times is equal to 100. 9 times 100 is a 900, and 9 times 1000 is a 9000. And then 100 plus a 900 is 1000, plus a 9000 is the same thing as a 10,000, and that's essentially the number that I started with over here. So that means that everything is right, right? Now you can do the subtraction. You can say essentially 0 minus 0 is equal to 0, 10 minus 8 is equal to 2, or essentially you can say what number do I need to add to 8 to get the 10, and then that number would be a 2. 9 minus a 9 is equal to 0, so which is essentially the same thing as, again, what number do I add to 9 to get the 9, which is a 0. And then 9 minus 6 is equal to 3, or essentially what number do I add to 6 to get the 9, basically, which is essentially a 3. So essentially the answer would be 3020. Okay? And if you do this on a calculator, the 10,000 minus a 6,980 would be the same thing as 3020. Right? Now this was the long version of this operation, but we can do it again. I mean, if you understand, basically, if you understand all the steps that I went through in order to break up essentially all of these numbers and everything, that every step that I went through over here, then of course you can do the short version. So I have essentially a 10,000 over here, and I want to subtract from that 6,980. Subtract. So then again, I need to borrow from here, and so I will essentially from a 1 I borrow a 1, so I get a 0 over here, and then the 1, when it comes to the next place value, when it comes over here, it becomes a 10, right? It has to become a 10 because of the reasons we just mentioned here. So a 1 comes to the next place value to the right, it becomes a 10. Again, the 10, I will make it a 9 and a 1. So meaning that I borrow a 1 from the 10. So 10 minus 1 is a 9, and then the 1 comes over here, becomes a 10, right? Again, I borrow a 1 from the 10, so 10 minus 1 is equal to 9, and then the 1 comes over here, becomes a 10. So again, you have 9, 9, 10, 9, 9, 10. Again, you can do the operation over here. Okay. Now, all of these are important because essentially you will use them in long division, which is very important in arithmetic, and also then you will use the same long division later on to do algebra, which is again important. You should understand essentially all of these processes to be able to do long division on variables in algebra. Okay, that's one more thing. And then again, basically, when you want to find the roots of numbers, meaning the square roots of numbers, the third root, the fourth root, the fifth root, and all of those things of different numbers, then again you will have to go through essentially an operation like essentially the long division. And well, to understand all of those things, you need to understand essentially these basic things that we have over here. Okay, and so the answer is 3020, and the 3020 is right over here in question number 2. Okay. Now the next question that we have is question number 3. We have, in an election, the successful candidate registered, that's 577,500, or essentially in the Indian system of numeration, that's 5,77,500 votes, and his nearest rival secured 348,700 votes. By what margin did the successful candidate win the election? So when you say by what margin did he win the election, so that means essentially what they're asking is essentially what was the difference between the votes that he managed to get compared to essentially to the next candidate, basically, right? So which means that essentially you want to find the difference between this number, which is the larger number, and this number, which is the smaller number. This is for the successful candidate. This is for the one who lost in the election. Okay? So to find the difference between these two numbers, again, you will write basically the first number. Essentially, the one who won the election was 577,500, and the one who lost basically was 348,700. Okay, so you want to find the difference between these two numbers. You would just simply write it as 577,500 minus 348,700, and then you would find essentially the difference over here, or you can write essentially 577,500 minus 348,700, and then basically subtract, and then you would find the answer over here. And in the answer, you can also find it over here. See, it seems that, of course, that the equal sign you don't really need it here. So you do not need the equal signs, only the subtraction sign, and that would be enough. Now, one thing that I need to tell you about these exercises is that basically I have gone through, well, I would say all of the exercises related to all of these NCERT books, starting from class 6 all the way up to class 12. And well, you have 7 books there from class 6 to class 12. That would be essentially 7 books. And in each book, essentially, you have something about 15 chapters. So 7 times 15 times, and in each chapter there is on average 3 of these sets of exercises. So that's around 315 essentially exercise sets, basically, meaning essentially 315 such exercises. For example, 1.1, 1.2, so 315 of such exercises. And well, around 3-4% of the time there are mistakes in these exercises. Sometimes something has not been typed properly. Sometimes there is even logical mistakes. Sometimes there is arithmetic mistakes. This kind of thing essentially sometimes is there around 2-3% of the time, not more than that. So when you use these, essentially when you use these solutions, you have to make sure that, well, sometimes if there is something wrong, there is some mistake, you have to be able to catch that mistake. If something doesn't seem to be right, or something hasn't been essentially typed properly, that sort of thing, you need to be able to catch it. Otherwise, they are perfect. Okay? And that's basically that. And you can, of course, always check your answers over here, meaning that, for example, for this calculation, you can always essentially use a calculator. But as I mentioned before, I highly recommend that you do essentially all of these calculations, all of the arithmetic parts of these exercises. Do each and every one of them, and do each and every one of them by hand, manually. Okay, don't use a calculator. You use a calculator, if you want to check your work, of course. So that's 577,500 minus a 348,700. That's 228,800, which is essentially the number over here. Okay. Now, question number 4, we have Kirti bookstore sold books worth 285,891 rupees in the first week of June, and books worth 400,768 in the second week of the month. The first week of June, and the second week of the month. So how much was the sale? How much was the sale for the 2 weeks together? In which week was the sale greater and by how much? So again, over here, basically, when you want to calculate the sale essentially all together for the 2 weeks, you will essentially take these two numbers, essentially add them together. That's simple. And then you want to know essentially in which week basically the sale was the sale number essentially was higher. So then you need to essentially compare the two numbers and see which number was larger. So wherever the number is larger, there essentially the sale was higher, of course. And then by how much? When they ask by how much, of course you want to find the difference between the two numbers, meaning that you want to do subtraction. That you will write essentially the larger number minus the smaller number, and then that would be essentially this, and the answer you can find it essentially over here. Everything is written over here, but well, you need to go through the operation, the whole operation, work with the numbers and all of those things essentially, and essentially sometimes you make mistakes, you catch yourself. It's fun, also a lot of learning, of course. Number 5, we have find the difference between the greatest and the least 5-digit number. The least means the smallest. The least 5-digit number that can be written using the digits, these digits each only once. So essentially you want to use essentially these digits in order to write essentially the greatest number that can be written using these digits. Of course, if you use the digits, essentially use each digit only once basically. And also the smallest number that can be written essentially using these digits. And then you want to find the difference between essentially those two numbers. So how do you do that? Okay, so the digits that I have are basically, this is question number 5, and the digits that I have are 627 and 43, and we want to write essentially 5-digit numbers. So the greatest 5-digit number would be this, and the smallest 5-digit number would be basically this, right? So for the greatest 5-digit number that you want to make, you want to essentially take the largest digit that you have, which in this case is a 7, and put it in the largest place value. So I put the 7 over here, again the largest digit in the largest place value. Again, the largest digit in the largest place value. And so on until you get to 76,432, right? For the smallest number, you want to essentially take the largest digit that you have and put it in the smallest place value. Meaning the 7 comes in the ones place value this time. And you can see the difference, meaning that, for example, a 7 in the 10,000s place value would be essentially a 7 times a 10,000, which is essentially a 70,000. But then a 7 over here in the ones place value is just a 7. Now you see that the difference between essentially a 70,000 and a 7. That's essentially the reason why we put essentially, in this case, essentially the largest digit, we put it in the largest place value. In this case, because I want to make the smallest number, the largest digit, I put it in the smallest place value. Okay. So then again over here, Then again over here, the largest digit, put it in the smallest place value, and then you put the 4 over here, the 3 over here, and 2 over here. So you have 23,467. And then you will find the difference between the two numbers. Write the larger number first, 76,432, and minus the smaller number, which is 23,467. And then when you do the subtraction, you'll have to borrow a couple of things from different places. So I borrow a 1 from the 6. You see over here I cannot. 2 minus 7, of course I cannot do, right? So I would have to borrow a 1 from here, right? But then if I borrow 1 from here, still I would need to, this would become a 2, and then 2 minus 6 still would not be possible. So from the very beginning I will borrow from over here, right? If I borrow a 1 from here, this becomes a 5, and then this becomes essentially the one that I borrowed. When it comes to this place value, it becomes a 10. A 10 plus a 4 is a 14, right? And then I borrow a 1 from here, this becomes a 13. The 1 comes over here, becomes a 10. 10 plus a 3 becomes a 13, right? And then I borrow 1 from here, this becomes a 12. And then the 1 that comes over here becomes a 10. So 10 plus a 2 is a 12, basically, right? So I mean, I could have borrowed essentially in 2-3 steps, but this way it's easier now. I can just simply do the calculation in one step, basically. So 12 minus 7 is equal to 5. 12 minus 6 is equal to 6. 13 minus 7 is equal to 7. No. So that's a 9. Now my mind is a little bit tired, so I cannot do arithmetic properly. So 9 plus 4 is equal to 13. 5 minus 3 is equal to 1. 7 minus 2 is equal to 5. And so the answer, the difference between the two numbers, the greatest number and the smallest number that we have created using these digits, is 52,965. And we can essentially check the answer over here. We have 76,432, 76,432, and 23,467, and then the difference is 52,965, which is correct, the correct answer. Okay. Okay, so question number 6, we have a machine on an average manufactures 2,825 screws a day. How many screws did it produce in the month of January 2006? Okay, so one thing that you need to know in these NCERT books is that you need to know essentially how many days each month of the year has, basically. Okay, so you need to know essentially how many days are there in January, in February, in March, and so on and so forth. You need to know that. And then basically and the way that you can, well, memorize this somehow, because there is no way to learn this, of course. You see over here I have basically 4 months over here that I have essentially that I have written, that for which I have written the number of months in the red color. These 4 months basically, which is essentially April, which is the 4th month, June, which is the 6th month, September, which is the 9th month, and 11 November, which is the 11th month, right? 4, 6, 9, and 11. So essentially the difference between 4 and 6 is 2, and the difference between 9 and 11 is also 2. That way you can probably remember the numbers. So 4 and 6, 9 and 11. In these 4 months, essentially, you will always have essentially 30, 30, 30, and 30 days, right? Next, basically, there is only 1 month which has 28 days. There is only 1 month which has 28 days. But then in a leap year, essentially, it seems that it has 29 days. But normally, essentially, 28 days. And that's February. And then the rest of the months, essentially, January and March and May and July and so on and so forth, the rest of the months essentially have 31 days, right? Which means that essentially January, which we are looking for over here, January essentially has 31 days, right? Now the question that was asked here is, we want to know essentially, on average, manufactures so many screws essentially in a day. Now we want to know how many screws it produced in the month of January 2006. I'm making the assumption that the year 2006 was not a leap year, and if it, which is again not a problem really. The leap year, it seems that it's only a problem when it comes to essentially to February. Otherwise, that doesn't, as far as I can tell, it doesn't make any difference, right? So we have 2,825, 2,825. Essentially, that's the number of screws that the machine manufactures essentially on average in a day. And we had essentially 31 days essentially in January. So you do the multiplication over here. And so 1 times 2,825 is 2,825, and then you would essentially you would put the 0 over here. As you remember in the previous videos when we talked about multiplication, we saw that essentially the second row always starts with the 0, meaning that you have to put the 0 and then the rest of the digits go to the left hand side of the 0. 3 times 1 is equal to 15, 1. 3 times 2 is equal to 6 plus 1 is equal to 7. 3 times is equal to 24, 2. 3 times 6, 6 plus 2 is equal to 8. And then you add these numbers together, you get a 5. You get a 7, you get a 15, 1. And 6 and 7 and 8. So then it has, in the month of basically January, it has the machine has created 87,575, which is basically 87,575, which is the number over here. Okay, so that's that. And again, these months, basically 4 and 6, 9 and 11, if you remember these 4 numbers, the difference between 4 and 6 is 2. The difference between 9 and 11 is 2. In these 4 months, essentially, we have 30 days. In February, we have normally 28, but then in a leap year, 29 days. Otherwise, in all the other months, we have 31 days. Okay, and essentially these pieces of information are very important, really important in computer programming. Meaning that if you want to do, for any sort of purpose, if you want to learn programming, or essentially if you want to become a computer programmer or something like that in the future, after a couple of years, of course, everything that we discuss essentially in all of these mathematics courses are important. But then, as you go through these exercises, there are many things that you will be able to use in computer programming later on. For example, when you read books like, for example, let us see is a book that you use in order to use the programming languages like C, C++, and, well, all of these different programming languages basically. If you do not, these essentially tidbits, these little pieces of information, you're going to get into a whole lot of trouble in those programming books basically. Okay, then you'll have to keep googling everything, so it becomes very useful pieces of information that you can collect all over essentially all of these textbooks basically. Now the next question is question number 7, which is: a merchant had 78,592 rupees with her. She placed an order for purchasing 40 radio sets at 1,200 rupees each. How much money will remain with her after the purchase? Okay, so we have 78,592 rupees, and we call this our capital basically, meaning that the amount of money that you have, right? And you want to buy essentially 40 radios, each costing essentially 1,200 rupees. This is essentially the order that she wants to place. And then the amount of money that remains after essentially making the purchase is going to be essentially this amount, 78,592 minus essentially this whole amount, which is, I put it in parentheses, 40 times essentially 1,200, and whatever remains here is the amount of money that remains after she's made the purchase. Okay, now this part essentially you can of course do yourself on a piece of paper, then check your answer. That's not a problem. But what I want to essentially point out is that this operation over here, I cannot write it as 78,592 minus 40 times, actually there is no problem, times to it. I can actually write it this way as well, and they would have the exact same meaning, because essentially when you have this kind of operation over here, there is essentially there is multiplication over here, and then over here there is subtraction, right? There is multiplication, and then there is subtraction, and then there is this priority of the 4 basic operations. First of all, you will have to start from the left hand side and move towards the right hand side, right? So when I start from the left hand side and move towards the right like this, what happens is that first I will come across the subtraction sign, and then I will come across essentially the multiplication sign. Now in the 4 basic operations, essentially the multiplication and division have the first priority, and then addition and subtraction have the second priority. So essentially, since multiplication has the first priority, first you have to take care of this part, meaning that first essentially you will essentially do this operation, 40 times 1,200, whatever that is, then you will subtract it from this number, meaning that this operation over here then comes basically, so this is operation number 1, and then operation number 2 would be this whole thing, this thing minus this part over here. Okay, this is important, otherwise if you don't understand, of course you could make mistakes, which is not very cool in mathematics. Okay, so that's all about that, and of course I can do that on a calculator as well. So 78,592 minus 40 times, which is not 78,592 minus 40 times 1200 is the same thing as 30,592. 30,592, which is the answer right over here. Okay, so now the next question that we have is a student multiplied 77,236 by 65 instead of multiplying by 56. So he has made a mistake. Instead of multiplying by 56, he has multiplied by 65. By how much was his answer greater than the correct answer? And as a hint, do you need to do both the multiplications? So you see over here what he has done. We have essentially a number which is 7,200. This is question number 8. 7,236. And he was supposed to multiply it by 56, right? And he has multiplied by, this is the mistake, he has multiplied by 7,236 by 65. Okay? Now, of course, since essentially 65 is greater than 56, the answer that comes out, which is essentially the mistaken answer, the mistaken answer that comes out will be essentially larger than the actual answer, right? Because essentially 7,236 times 65 is going to be larger than 7,236 times 56, because of the fact that 65 is greater than 56, right? Now, what we want to know is by how much is the answer going to be larger, right? So what is the difference between 56 and 65? And the question is by how much was his answer greater than the correct answer? What is the difference between 56 and 65? And 65 minus 56 is the same thing as, if I borrow 1 from here, that becomes a 5, that becomes essentially a 15. 15 minus 6 is equal to 9, and so the difference is a 9, right? So since the difference is a 9, then of course the difference between essentially the two answers is going to be essentially 9 times 7,236, right? The reason is that when you multiply, for example, 7,236 times, for example, I don't know, let's say, for example, a 56, right? What this means is that essentially that's the same thing as 7,236 added to itself 56 times, right? 56 times added to itself. Or essentially when you say, for example, 3 times of 4, right? This means essentially 3 added to itself 4 times. This is the same thing as 3 plus 3 plus 3 plus 3. By the same logic, 7,236 times of 56 is essentially 7,236 added to itself 56 times, right? Over here, when you say 7,236 times 65, that means essentially the same number added to itself 65 times. So now what is the difference between 65 and 56 times? That's essentially 9 times. So that means essentially the difference would be 7,236 added to itself 9 times, or essentially 7,236 times a 9 basically. That's going to be the difference, right? That is going to be the difference. And you can do this operation over here. So 7,236 times a 9, that's a 9 times 6 is equal to 54. And then 9 times 2 to 27. 27 plus 5 is 32. 9 times 2 is equal to 18. Plus 3 is equal to 21. 2. And 9 times 2 is 63. 65. That's 65,124. So this is supposed to be 65,124. I just want to make sure that I didn't make any mistakes. So 7,236 times 9 is 65,124. Now this is supposed to be the difference, right? Now let's take a look at both the operations. So I have 7,236 times 65, which is what the student has done by mistake. That's 470,340. Now the same number, 7,236 times basically now a 56. That's a 405,216. Now if I take the difference of these two numbers, it's going to be 65,124. 65,124 that we have calculated here. Okay. And hopefully you have understood essentially what I discussed here. You see because of the fact that essentially a 65, because of the fact that the 65 is a 56 plus a 9, we can say that essentially 7,236 times essentially a 65 is essentially nothing but basically 7,236 times basically a 56 plus a 9, right? When you say essentially 7,236 times a 65, and we know that a 65 is a 56 plus a 9, then we can write the same thing as 7,236 times a 56 plus a 9. Now this thing over here is the same thing as essentially when you have these two numbers added together, you have essentially addition over here. You have basically addition over here, and then you have multiplication over here. So we say that essentially multiplication distributes over addition, meaning that if I have essentially a times, for example, a b plus c, for example, let's say that this is a, this is b, and this is c, then this is the same thing as a times b plus, of course there is multiplication. Let me write this properly. When I have a times b plus c, I can distribute this. I can distribute the multiplication over the addition and distribute it this way. So a times b plus, the plus comes from here, and a times c, right? And of course in algebra, later on when we use algebra, we will just simply write this whole thing. We will write it as a times b plus c is equal to a times b, which is ab, plus a times c, which is ac. We will write it this way. Both essentially mean the same thing. Okay. So based on this, we can say that essentially this part of the calculation is essentially 7,236 times a 56 plus, this is one part, a 7,236 times a 9 basically, right? And this is the same thing as 7,236 times a 65. So now the difference between essentially these two calculations, you can find the difference essentially, meaning that essentially we can essentially write, you see that this is 7,236 times 65, and then this whole thing I can bring it to the other side, but then I have to change the sign, meaning that the sign over here, right now the sign is positive, meaning, for example, like the positive that we have over here, there is a positive over here in algebra that we don't write it, okay? So then I bring this whole thing to the other side, but then it changes sign. When it changes sign, it becomes minus 7,236 times a 56, okay? And then the equal sign, and then what remains on the right hand side is just this part over here, which is 7,236 times a 9 basically. Now this part over here is automatically the difference between what the student was supposed to calculate and what the student essentially calculated by mistake, which is what we were trying to find out here. So the difference between the two is just 7,236 times a 9, and the 9 is nothing but the difference between 65 and 56, right? And we calculated this as 65,124, which is essentially the difference between the two calculations, okay? Now if this was a little bit, I mean, hopefully of course you understood it, but then later on we will have a whole lot of such exercises, and we will get more familiar with algebra and all of those things basically, okay. So next we have question number 9. Now we have to stitch a shirt, 2 meters 15 centimeters cloth is needed. Out of 40 meters cloth, how many shirts can be stitched, and how much cloth will remain? So we have essentially the amount of cloth for one shirt is 2 meters 15 centimeters, and the total amount of cloth that we have is 40 meters. Now you need to essentially, we want to know essentially out of 40 meters cloth how many shirts we can stitch, given that essentially one shirt essentially needs 2 meters 15 centimeters of cloth basically. So how do we calculate that? So of course when you want to multiply things, for example, when you want to divide things, when you want to add things, when you want to subtract things, of course things have to be essentially in the same units, otherwise your operation is not going to make any sense. For example, if I say that the length of a door is, for example, 96 centimeters, and the length of a table is, for example, 0.5 meters, for example. Now, what is the length of the two altogether, basically? And then, of course, you might think that, well, over here, I can just simply add the two lengths together to get essentially the lengths of the two things essentially altogether, basically. And then you would say, if you say that, for example, 96 plus a 0.5, that would be essentially 96.5 basically. And then what is the unit for that? Is it centimeters or meters, right? So although essentially these are both basically lengths, right? These are both lengths. in spite of that, you cannot add them together because one of them is in centimeters, the other one is meters, meaning that essentially, I mean, technically this would be, for example, 96 centimeters. This is actually 50 centimeters. It's 0.5 meters is actually 50 centimeters. So then if you were to add these together, you cannot do it this way. You have to write 96 centimeters plus a 50 centimeters, and now you can add 96 plus 40 is essentially 146 centimeters, and now the unit is centimeters. Now you can even convert to meters, for example, write it as 1.46, for example, meters. You can do that, but first, essentially, before doing any sort of operation, you have to make sure that both essentially are in the same unit, basically. Okay. Now, coming back to this problem, you have to what we need to do is that we can essentially let's take a look at the solution. Let me see how they have done this over here. It's question number 9. And what they have done is basically the cloth required to stitch one shirt is 2 meters 15 centimeters, 2 times essentially 100 centimeters plus 15 centimeters, which is essentially 215 centimeters. So they have converted everything essentially to centimeters, and then the length of the cloth is again in centimeters, and then so what they have done, as I mentioned before, you need to essentially bring everything essentially in one unit. Okay. So so then what you can do is that, for example, 2 meters 15 centimeters, essentially these are essentially in mixed units. Meters and centimeters are both together. So instead of 2 meters, you would write 2 times 100 centimeters, which is essentially 200 centimeters, plus 15 centimeters, that would be essentially 215 centimeters. And then the length of the cloth is, well, 40 meters, which is the same thing as 4,000 centimeters. And then the total amount of cloth that you have, if you divide it by the amount of cloth that you need for one shirt, then when you do the operation over here, you will get essentially the number of shirts that you can stitch, right? So essentially here what you need to do is that, of course, you need to make sure that you understand the solution, and at least this operation over here you need to do it once on your own. And believe me, when you essentially do these things for the first time, you might actually think that you can do this, but then when you go through the operation, then you will find out that you will essentially get stuck here and there a couple of times, and then you need to essentially find out what sort of mistake you made. So these are essentially all part of learning. These are all part of learning, and unless you go through the exercises, you're not going to know when you might essentially have a problem. Okay, so now the next question that we have is basically medicine, question number 10, which is medicine is packed in boxes, each weighing 4 kilograms, 500 grams. How many such boxes can be loaded in a van which cannot carry beyond 800 kilograms? Now what I'm going to do is that, well, I'm going to actually solve the problem over here, but there is essentially this problem that we need to solve here now. I mean, I had actually forgotten that there is all of these problems that we were actually supposed to solve, and essentially most of these contain problems containing units, basically, and these units, of course, you need to understand them. So what I'm going to do is that then after essentially these videos, I'm going to do a single video essentially, and I will describe essentially all of these different units and everything that comes in the AI system and everything that you need to know so that you can actually work with this system properly. Okay, but for now let me solve this problem. You see over here we have basically each box of medicine. I'm not sure if I actually read the question. Each box of medicine is packed in boxes, each weighing 4 kilograms, 500 grams. Now, how many such boxes can be loaded in a van which cannot carry beyond 800 kilograms? Okay. So, this means that essentially each box of medicine essentially weighs 4 kilograms, 500 grams, which is essentially what this means is that 4 kilograms plus a 500 grams. And the van cannot carry beyond, essentially beyond 800 kilograms. So then how many boxes of medicine can we carry in this van, right? So what I need to do is that essentially the total capacity of the van is 800 kilograms, right? So if I divide the total capacity by the weight of each box basically, then whatever comes out of division is going to give me essentially the total number of boxes that I'm allowed to essentially to load into this van basically, right? So let me say this one more time. So let's say that essentially if I say that essentially the weight of one box of medicine, right? Suppose that, for example, one box of medicine essentially weighs, for example, 2 kilograms, right? If I have essentially, for example, 20 of these boxes, what's going to be the total weight? So then it's going to be essentially a 2 kilogram plus a 2 kilogram plus and so on and so forth. And that would be essentially, since I have 20 of these boxes, that would be 20 times. So this is essentially, instead of adding 2 kilograms to itself, essentially 20 times, I'm going to write essentially 2 kilograms times essentially 20, which is essentially, for example, 40 kilograms. So then, essentially, then the total weight of all the boxes, all the 20 boxes all together is going to be 40 kilograms, right? So we have the exact same type of question over here. If I have essentially the weight of one box times essentially the total number of boxes, then this is going to be equal to essentially the total weight of essentially all the boxes. Right? So again, we have the weight of one box, so the weight of one single box, times basically the total number of boxes. So for example, suppose that the weight of one box is 2 kilograms, and essentially in total I have, for example, 20 boxes. So 20 boxes times basically 2 kilograms, that would be essentially 40 kilograms. That would be essentially the total weight of all the boxes essentially all together, right? So then I will do the exact same thing over here. I will say that basically that the weight of essentially one box is 4 kilograms plus essentially 500 grams, grams. Now 4 kilograms, and we will see this in the next video, that 4 kilograms is the same thing as essentially 4,000 grams plus essentially 500 grams, which is essentially the same thing as 4,500 grams. Right? So then we have essentially 4,500 grams times essentially the total number of boxes. I don't know, because essentially the question is actually asking the same question, that how many boxes can we load into this van basically. So I'm going to say times x basically. So the total number of boxes, I don't know, is going to be equal to the total weight of all the boxes. And in this case, the total weight is essentially the allowed weight that you are, essentially the weight that you are allowed to essentially to load into the van. And here we said that essentially the van cannot carry beyond 800 kilograms. So then I'm going to set the weight to 800 kilo, the total weight, I'm going to set it to 800 kilograms, right? I'm going to write that as 800 kilograms, right? Now you see that over here, essentially there is a problem over here in the equation that I have written. In my equation, essentially this weight is in grams and this weight is in kilograms. And of course it's going to cause problems, because essentially in a single equation, well, of course all the weights have to be, essentially all the weights have to be the same basically, otherwise it's not going to be an equation in the first place. So instead of 800 kilograms, and again we will see in the next video that 800 kilograms is actually equal to 800,000 grams basically. So then I'm going to write essentially 4,500 grams times an x is the same thing as 800,000 kilograms. Excuse me. That's essentially in grams. Now it is in grams. And now that essentially now that we have the same units, I can actually simplify grams and grams from essentially from both sides of the equation. Okay? So I can, for the sake of simplicity, I can simplify them. And essentially that is, even if you do not simplify this, so when you want to solve the equation, then the gram and gram will automatically be simplified, meaning that to solve this equation, then you will say that, for example, that the number which is alone on one side of the equation, which is essentially 800,000 grams basically, this number over here, if you divide it by any of these two numbers basically, whichever one helps you. So of course I don't want to divide by x because I don't know what x is, but I can divide by 4,500 grams basically, is equal to the other number, which is equal to x, right? So this way I can get to x. And well, grams and grams in the numerator and denominator you can cancel out. And then basically, to make this simpler, I can essentially divide both the numerator and denominator. We saw essentially in the problem with the proportions that the numerator and the denominator of a proportion, you can multiply it by any number that you want, although provided that you essentially multiply the numerator and the denominator both by the exact same number, meaning that if the numerator is multiplied by 2, the denominator is if the numerator is multiplied by 2, the denominator is also supposed to be multiplied by the same number 2 essentially, meaning that you cannot, for example, take the numerator multiplied by 2 and then the denominator multiplied by some other number. It's just not right basically. And in the exact same way, we saw that essentially both the numerator and the denominator could be also divided by the same number, right? So then I'm going to write this as essentially, well, instead of 800,000, I'm going to write essentially 8,000 times 100. That's essentially 800,000. So I haven't changed anything over here. And instead of 4,500, I'm going to write a 45 times 100. And now essentially the 200s I can simplify from the numerator and from the denominator. So the hundreds I can simplify here. And now the operation essentially becomes the 8,000 divided by 4,500. Now I don't have the time for this. I mean, I would do this long division, but I don't want to waste your time. You can do it on your own. 8,000 divided by 45, it's 177.78 basically. It's 177.78 basically, right? And what is this x that we have calculated here? This x was supposed to be essentially the total number of boxes. This is essentially this x that we have over here. We said that the weight of one box, which is 4,500 grams, times the total number of boxes, which we took as x because we didn't know what that was supposed to be equal to the total weight of all the boxes, which was essentially 800 kilograms. So this x over here is the total number of boxes. So then the total number of boxes is 177.78 essentially boxes basically, right? But now you need to understand that there is no such thing as, for example, 2.5 boxes. You have either 2 boxes or essentially 3 boxes. But 2.5 boxes essentially simply does not exist. Meaning 2.5 boxes, that doesn't make any sense, right? Essentially the number of boxes has to be a whole number, either 2 boxes or 3 boxes or 4, but 2.5 boxes would be somewhere between 2 and 3 boxes, which doesn't make any sense, right? So now this number, basically we have to round it essentially. We have to round it, and in the next sections of this chapter, we will see essentially how we can round numbers. But for now, it's enough to know that essentially 177.7 is essentially some number. So essentially, if we have a number line over here, let's say that this is 177, and this is 178. And then we have, for example, somewhere over here, we have 179, and so on and so forth, right? Now, this number, essentially we have 177 here, 178 here, 179 here, and 170.7 would be somewhere over here. So that would be 107.7 basically, meaning essentially some number between 177 and 178, right? So you have to essentially round this number either to this number, meaning you have to round down, or you have to round the number to this number, which is round up, right? Meaning you have to round the number either to 177 or to 178. You cannot keep it as 177.7, right? Now, if I round this number up, I'm going to get into problems, because essentially 178 times basically 4,500 grams is going to be above the allowed limit for the van basically. But if I round down to 177, then I'm going to still be within the limits for the allowed weight for the van basic. And I show you essentially what I mean by this. So if I write basically 177, or essentially 178, if I round up basically 178 times 4,500 grams, it's going to be 801,000 grams, which is essentially 801 kilogram. And we said that basically that the allowed weight is 800 kilograms, not 801. So of course I cannot use 178. But if I use 177 and times 4,500, it's going to be essentially 796,500, which is essentially 796.5 basically kilograms, which is below 800 kilograms, right? So I'm going to round down, and I'm going to say that essentially 177 boxes can be loaded into the van basically. Okay, not 178. Okay, so that's that. So about rounding, of course, we are going to read in the next section, so that's not the problem. And this problem seems to be taken care of without any problems. And of course the units we will do essentially in the next few videos, so we have no problems. We can go forward. Now the next question that we have here is question number 11, and it says the distance between the school and a student's house is 1 kilometer 875 meters. Every day she walks both ways. Find the total distance covered by her in 6 days. So you can essentially what you need to do is that you need essentially she goes essentially back and forth, meaning essentially every day she's going to walk essentially a distance of 1 kilometer 875 meters times 2, because essentially this distance she has to cover when she goes to school, and the same distance she has to cover when she comes back home. So essentially for one day that would be 1 kilometer 875 meters times 2, and then essentially this whole distance is going to be covered essentially in 6 days. So essentially that whole thing is then going to be multiplied by 6 basically, right? So I'm going to do this as well because these might be a little tricky and they need to be understood. So the distance, basically this is question number 11, and the distance between essentially the school and home is 1 kilometer 875 meters, which is essentially 1 kilometer plus 875 meters, right? Now since essentially she covers this distance twice every day, meaning once she goes to school and then she comes back home, then the total distance every day would be essentially 2 times this distance, which is 1 kilometer plus 875 meters, right? Now and then essentially then the total distance in one day, essentially in 6 days, would be essentially 6 times this whole distance. Would be essentially 6 times 2 times 1 kilometer plus 875 meters, right? So now what I need to do is that I need to essentially of course you can directly multiply, there is no problem, meaning that you can multiply 2 by 1 kilometer and multiply 2 by 875 meters, right? And then again multiply 6 essentially by both of those things, but then it gets unnecessarily complicated. So we know that essentially 1 kilometer is the same thing as 1000 meters, right? So I can write this as 6 times essentially 2 times, and then essentially 875 plus 1000 is the same thing as 1875 meters, right? So then we have 6 times 2 times 1875 meters, which is the same thing as 6 times 12 times 1875 meters, right? And then you can do this essentially, of course you have to do long multiplication. 1875 times 12, and then do the multiplication, and then whatever you get over here, that would be the distance in meters. But then I'm going to do this on a calculator, and you need to make sure that you do this essentially as a long division yourself, essentially manually. 1875 times 1875 times 12 is 22,500. So that's the same thing as essentially 22,500 meters. And now if you want to essentially, and we will see essentially all of these in the units, I don't want to unnecessarily take too much time over here. So the 22,500 meters, if I divide this by 1000, I will get 22.5 kilometers. Okay, so that means that essentially that's essentially the total distance that is covered essentially in 6 days. That's 22.5 kilometers. And hopefully we have done everything right, and we will see that that's essentially 22.5 kilometers. Okay? Or essentially you can say essentially 22 kilometers 500 meters. That's also the same, the right thing to say. Again, basically question number 12, we have basically a vessel has 4 liters and 500 milliliters of curd. In how many glasses each of 25 milliliter capacity can it be filled? So we have essentially 4.5 liters of curd, and we want, and the capacity of each glass is 25 milliliters. And then we want to know essentially how many glasses can be filled using essentially 4.5 liters. So question number 12, we have essentially the total amount of curd that we have is essentially 4 liters 500 milliliters, and the capacity of basically of one glass is basically 25 milliliters, right? So then how many glasses can we fill? Now for the solution, now you see that essentially I have 4 liters 500 milliliters, and then I have milliliters here. So I'm going to essentially convert all the units to milliliters, and here you need to note that essentially 1 liter is equal to 1000 milliliters, right? So then I'm going to say that basically 4 liters 500 milliliters is the same thing as essentially 4 liters plus a 500 milliliters, right? Which is the same thing as essentially 4 liters would be essentially 4 times 1 liter, which is 4 times 1,000 milliliters, which is 4,000 milliliters, right? You see over here, if essentially 1 liter is 1,000 milliliters, then 4 liters would be essentially 4 times, essentially 4 liters would be 4 times 1 liter, which is 4 times 1,000 milliliters. So that's essentially 4 times 1,000 milliliters plus a 500 milliliters, which is the same thing as 4,000 milliliters plus a 500 milliliters, which is the same thing as 4,500 milliliters, right? Okay, so now you need to set up your equation, which is essentially an important step. If you make a mistake here, then everything is going to be wrong. You see, your logic has to be right. You see, we have essentially all of this curd, which is about 4.5 liters. We want to fill as many glasses as we can, keeping in mind that each glass essentially has a capacity of 25 milliliters, right? So I'm going to say that essentially the capacity of one glass the capacity of one glass times essentially the total number of glasses is going to be equal to the total amount of curd, basically. You see, the capacity of one glass is, for example, 25 milliliters. If I have basically, for example, one glass, that would be 25 milliliters. Or you can essentially make it even a little bit simpler to understand if you cannot understand this, my logic over here. You see over here essentially the capacity of one glass is 25 milliliters. So you have 25 milliliters plus another 25 milliliters and so on, and plus another 25 milliliters plus another 25 milliliters plus so on and so forth. And you have to do this as many times as necessary, meaning essentially you have to do it as essentially equal to the number of glasses that you can fill, right? You don't know how many times. So essentially as many times as the total number of glasses as many times as the total number of glasses. And because of the fact that I don't know what is the total number of glasses, I'm going to call it X, basically, right? I'm going to call this X. So essentially all of this, when you put it together, this is supposed to become essentially the total amount of curd that we have, which is essentially 4,500 milliliters, right? So this is supposed to be 4,500 milliliters, and that is simply because we don't have more than this amount of essentially curd, basically. Now if I essentially add 25 milliliters to itself X number of times, then essentially that's the same thing as essentially X times 25 milliliters, right? You see, for example, if I add 25 to itself, for example, 5 times, that would be the same thing as 25 times 5, basically. If I add 25 to itself, for example, 8 times, that would be 8 times 25, basically. So then if I add 25 to itself x number of times, that would be essentially 25 times x is equal to 4,500 milliliters. If you ever get into trouble setting up your equation, or if you're not sure your equation is essentially right, do something like this. Essentially start from the very basics, meanings, and essentially adding things together. Then out of that addition, you can essentially create some sort of multiplication, and then you can simply solve the problem. And that way, essentially, you know that your logic is right, basically, and your equation is therefore also right. Now this is 25 milliliters, and then this is just a simple equation. So the number which is on the one side of the equation, which is alone, I'm going to write it as 4,500 milliliters and divided by one of these numbers, either 25 milliliters or the x, basically. So I'm going to divide by 25 milliliters. That's going to be equal to the other number, which is x. So this way we can calculate x. Now milliliters and milliliters we can simplify. And then what is 4,500 divided by 25? Of course, all of these problems, ideally, once you essentially watch all of these videos and you understand essentially all of the different points that go into each and every exercise, you need to do each and every exercise. Once you've understood it, it's okay. Now you know the solution, but do the exercise and write your solution down. Okay? Now these are the little things in mathematics, and I cannot emphasize these little things. I cannot emphasize them enough, that when you do, essentially when you actually follow each and everything that I mentioned here, then at the end of this, essentially at the end of all of these courses, which might take you, I don't know, it's 7 classes, it's going to take a while. But then at the end of this process, if you, for example, if you do essentially exactly what I say here, meaning that although you have actually watched essentially what you have actually seen the solution, you have watched the solution on the video and everything, and you have understood it, but still write it down. Okay? Write it down on a piece of paper in your own handwriting. And of course, every step of the way you have to understand your own solution. And then essentially all of these things will automatically in your mind come together, and then they will create this beautiful, very beautiful foundation of mathematics. And then using this beautiful foundation, there is like nothing that you cannot do really in mathematics. Then you're simply equipped with everything that you need in mathematics. But you actually need to do it. Okay, you need to take the time, essentially every time, write down the solution. All of these things are absolutely important. Okay, so then basically a 4,500, and if I divide that by 25, that's going to be 180. So then x is going to be essentially 180. So that's exactly the number of glasses that you can fill using essentially 4,500 milliliters of curd, given that essentially the capacity of each glass is 25 milliliters. And you can see over here that essentially 180 glasses can be filled by curd. 180 glasses. Okay, so what remains for me now to do in the next video, and I thought I could just simply not discuss this, but seemingly it's just simply not possible. So in the next video we will talk a little bit about the SI system of units, and essentially all the prefixes in the SI system. Thank you.